Question 9. For this question, you have to know the Eulerian form of the complex number, where a plus bi can be written in r times e to the power of I theta form. Here, a and b is a real number and the imaginary number. So if you plot in the real and imaginary coordinate, you will get such. Here, our example complex number is a plus bi. If you draw a circle that has center of origin and it passes through this a comma b point, you're gonna have radius, which is our r, and then the angle between real axis and then the line that connects the origin and a comma b becomes our theta. So if you zoom up here, you can find your r that's equal to a squared plus b squared using Pythagoras theorem, and you can find a theta by finding arctangent of b over a. Now using that, our formula on the right hand side is root 2 minus root 6i. Therefore, our real number, or a, is root 2. So r is square root of root 2 squared plus, and b, which is our imaginary number, here is minus root 6. So you square that again. And that becomes 2 root 2. And theta is arctangent minus root 6 over root 2. And make sure your calculator has radian as angle unit. Then this becomes minus pi over 3. However, this theta is not the only answer, because we are looking for theta in between 0 and 2 pi. We want to make sure we're getting all the theta within this range. So one good way that I use to think is that, okay, our theta is minus 3 over pi, so it's somewhere here. Okay? What if this turns all the way and then come back here? Then it means it's theta, all the theta plus 2 pi. Or if it turns another round, it becomes theta plus 4 pi. Or it becomes theta plus 6 pi. Because there, all the theta can be added with 2 pi or multiplication of the 2 pi. One hint that I use normally where to end is finding the highest power in your question. Here, the highest power is 3 because we have z to the power of 3 term. Just in case, you just do 3 or more. So this can be either 5 pi over 3, 11 pi over 3, or 17 pi over 3. So our equation is that z to the power of 3 is either 2 over root 2 e to the power of minus pi over 3, or 2 root 2 e to the power of 5 pi over 3, and so on. These are all the possible answers. Now we're looking for z, not z to the power of 3, because we're solving this question, okay? So as cube root of 2 root 2 is just root 2, it becomes root 2. As you have to do both on number and exponent, this becomes minus pi over 9, 5 pi over 9, and so on. I just did one more theta here at the end to really show what I'm going to eliminate at the end. Because we want our theta to be within 0 and 2 pi, minus pi over 9 is not in the range. 5 pi over 9, 11 pi over 9, 17 pi over 9 is all within the range. Whereas the last term that I added, 23 pi over 9, is not within 2 pi because it's higher than 2 pi. So this is also eliminated. This is where you stop. Therefore, 3 answers are these. Oh, don't forget your i's. Exponents should have I, so always don't forget, okay? Because z is r e to the power of theta I. Question 9b. First, you have to know the area of triangle formula using a sine formula, which is 1/2 AB, which is the length of the triangle, and sine theta, the angle between those two lengths. Second thing you have to know for this question is that for transformation matrix A, any area change caused by it is equal to the determinant of the A. So let's say our three roots we found in previous section, Z1, Z2, and Z3. All roots have r, which is a length from origin to the root, equal to root 2. So they are in one circular position, Z1, Z2, and Z3, like this. And if you see the theta, which is 5 pi over 9, 11 pi over 9, 17 pi over 9, you can see that they are differenced by 2 pi over 3. So I plot as angle followed. So it looks like a perfect triangle here. As I said, all the angle between each root is equal to 2 pi over 3. So let's think about this tiny triangle first, which is exactly 1/3 of the triangle that formed by three roots. So by applying the area of triangle formula, this length is r, which is root 2. This is also r for z2, which is square root 2. Then our a and b are both square roots 2. We substitute into this equation 1/2 a, which is a length of r, again a length of r for z1 and z2. And then the angle between those two lines is a theta difference, which is sine 2 pi over 3. And as I said before, this yellow highlighted area is 1/3 of the area that we want to find. So everything times by 3. And this will give you 3 root 3 over 2. This is the area that we want to get. So area of the triangle. And then now we have to find a matrix determinant for our M. So determinant of the M is 5 times 3, which is this diagonal, and then we subtract that by multiplication of the other diagonal, which will give you 14. Now the area change is that the area of triangle before transformation times by a matrix, transformation matrix as such. So that is 3 over square root 3 over 2 times by 14. Therefore, the new area is 21. First, you need to find a line vector form equation for line AB here. And I wrote down the general vector form for the line where r is equal to position vector plus mu, which is a scalar value, times by a direction vector. So let's start with A. And then the line extends to B like this. And let's say this is our starting position vector, P. Then our equation of r becomes the coordinate of the A, 5 minus 4, 6, plus any scalar value multiplied by a direction vector. In order to get the direction vector, here we want the line that extends from A towards B. Okay, then we need to subtract the position vector B with the position vector of A. Then the x part of B is 6, x part of the A is 5, and then you repeat that, which becomes this. So this is a equation for line AB. And here comes a C, which is another position like this. Now we want to find a D on the line AB, which is closest to the C. The closest mean that it has to come down to the line 90 degrees. Imagine like other lines. Those should be longer than these perpendicular lines. So always the closest one is a 90-degree one. So that point is our D. We're not sure what coordinate of D is, but we know that D is on the line AB, so it should follow this general equation for the line equation R. Let's say our D has arbitrary coordinate x, y, and z. then xyz should be equal to 5 minus 4, 6 plus mu 1 minus 2, 2. And we're not sure what mu is because mu can be any number like 0, 1. If it is 0, it should be just a here. If it is 1, it goes more here. 2, it goes more there, and so on. So if you combine these two brackets, it becomes this. Now we want to find a exact mu value by using the fact when two lines are perpendicular, their dot product should be equal to 0. Here we emphasize that line CD and line AB are perpendicular to each other because we want the D to be closest to C. So what that means is that our direction vector, because that is a actual vector that crosses line CD, dot product or scalar product with CD should be equal to 0. So we know the direction vector of the line, which is 1, minus 2, and 2. In order to get CD here, CD is equal to position vector of D minus position vector of C. So that is 5 plus mu. We found this is a D coordinate. D coordinate. Minus 4 minus 2 mu, 6 plus 2 mu, subtracted by C, which is given in the question, 15 minus 5 and 9. Therefore, our CD is equal to this. So you dot product with our direction vector of the line, and that should be equal to 0. Remember, the dot product ABC dot DEF is equal to this. So first line multiplied, second line multiplied, third line multiplied, and add them together. So this becomes like this equation. This is just the definition of the dot product. And then if you simplify this equation, this and our mu is equal to 2. Now we found exact mu value. So our D, which was this, and then we're gonna substitute mu into the general form we found, then it becomes this, 10b. The question also starts with hints. Again, go to part A and then find any useful information from there and then apply to part B. Here it's asking for the shortest distance between C to L, and we found that it was actually the length of the CD, right? Because the D was the closest point to C, okay? And then from part A, we also found that mu was actually 2. Then if you substitute mu into this line equation, we can know that CD is equal to minus 8, minus 3, and 1. Now, in order to get the length of the vector, for example, ABC, then you square all the components, add them together, and put them all into the square bracket. So our length of CD is square root 70. Question 11 is a typical differential equation problem, and it is a first order, meaning the highest order of the differentiation, which is dy dx, is 1. We have to know the general form of the first order differential equation, which is given in the first line, dy dx plus certain equation of x, px times by y, and that's equal to qx, another equation in terms of x. And then you have to know what integrating factor, or I'm going to call it IF in this video, which should be e to the power of the integration of the p in terms of dx. This p multiplied in front of the y in the second term. First step is to follow the general form, which is written in the first line. Here we have x in front of dy dx, and we don't want that. So in order to remove it, we're gonna divide the equation through by x as such. Now we know that this is our differentiation equation, the first term. In the second term, px is minus 2 over x, and qx is the right hand side of the equation. The important part is px because of the second step, which is to find a integrating factor. IF. We integrate px dx, which is, for our case, minus 2 over x. As number can go out of the integration, minus 2 can come out, and 1 over x dx is left. And the integration result is ln x as such. Okay, this is another basic integration rule that you have memorized. And then this is not the end of if. If is exponential of the formula we just found, which is minus 2 ln x. And this can be written as e to the power of ln x to the power of minus 2. And e and ln can cancel out each other, and then this gives you x to the power of minus 2. And this is your if. And then step 3, we're going to multiply the found if throughout all the equations. So we're going to multiply first equation we have. Then it becomes this. And if you check this left-hand side, it's actually a result of the product rule of d dx y times 1 over x squared. Right? If you recall the product rule, if you differentiate fg, then it should be equal to f differentiated times by g and plus f times g differentiated. So if you differentiate y, it becomes dy dx, and then it's just multiplied with the second term, which is 1 over x squared. So it gives your first term on the left. And if you do the vice versa, you leave the y behind, differentiate the 1 over x squared. It gives you a second term, which is minus 2y over x to the power of 3. And then the right-hand side, live as such. And the next step is to integrate both sides in terms of dx as this. Left-hand side is a integration of the differentiation. So it just gives out whatever function is within a differentiation bracket. So left-hand side becomes y over x squared, and that's equal to integration of 1 over square bracket 4 minus 2x minus x squared. So whenever there is a square root in your denominator and the formula within a square root has a square term, as this case, you first try to complete the square inside the square root. So it gives you 5 minus x plus 1 squared. So why are we completing the square? Because if you see your formula booklet, there is a differentiation tab where it has a very similar form of the differentiated result, which is a differentiation of the inverse sine and inverse cosine. So for our case, it's very similar to inverse sine differentiation result. But we don't have 1 in front of something squared, so we're gonna pull out the root 5 in front of the denominator. So that'll give you root 5 times by 1 minus x plus 1 all over root 5 squared. 1 over root 5 move out from the integration, and then it gives you that left. This is very similar to sine inverse differentiation result, but we have a certain function within a x. So we have x plus 1 over root 5 instead of just simple x. So you have to differentiate whatever in the bracket. And if you differentiate this function, it gives you 1 over root 5. And if you have certain function in it, whenever you integrate it, you have to divide it by 1 over root 5, or the differential result of the complex function within. So that's 1 over root 5 divided by 1 over root 5 times by the result of the integration, sine inverse x plus 1 root 5 closing square. And that will give you this. And never forget your C sign, which is a constant behind your result of the integration where there is no limit. This is a very easy mistake to make, so always put the constant term after your integration. And this is only the right hand side, and your left hand side was y over x squared. And your right hand side is whatever results you just got from the integration. So if you simplify this equation in terms of y, it becomes